Good morning, my dear young minds. Welcome to today's session of Class 10 Science Chemistry Chapter 1 Chemical Reactions and Equations. In our previous class, we discussed about types of chemical reactions. In that, we have completed chemical combination reaction and chemical decomposition reaction. Today, we are going to discuss about chemical displacement reaction and also chemical double displacement reactions. Before going to discuss about chemical displacement reaction, we should know about reactivity series. This reactivity series is also known as activity series. Students, it is very essential to know about reactivity series. I will define the definition of reactivity series. Listen carefully. The arrangement of metals in a vertical column according to their decreasing reactivity is called reactivity series. Once again, I am repeating the definition. The arrangement of metals in vertical column according to their decreasing reactivity is called reactivity series. It is also called activity series. Here, students, I have written all the elements in a vertical column. See, sodium, potassium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold. And these some of the metals we arranged here in a vertical column according to their decreasing chemical reactivity. See, first one is sodium. First one is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver and gold. So these are the decreasing order of the reactivity of the metals. And here in this vertical column we can see the topmost metal, which is potassium. It is highly reactive, and at the bottom there is a gold. It is low reactive element. So the elements which are placed at the top of the reactivity series are called more reactive elements, and the elements which are placed at the bottom of the reactivity series we will call less reactive elements. So children, if we know this reactivity series, we can able to understand about chemical displacement reactions. So based on this chemical reactivity series, I would like to tell you that this potassium is more reactive element, so that potassium can easily displace zinc, potassium can easily displace iron, potassium can easily displace tin, potassium can easily displace lead. Why? Because it is high reactive element and these are low reactive element. In the same way, see students, here zinc metal is highly reactive than iron, so that zinc can easily displace iron, iron can easily displace tin, tin can easily displace lead, so lead can easily displace copper, lead can easily displace mercury, lead can easily displace silver, lead can easily displace gold. So based on this only we can able to identify whether the given chemical reaction is a displacement reaction or not. So to understand about displacement reactions, this chemical reactivity series is very important. Once again I am repeating the definition. The arrangement of metals in the order of decreasing their reactivity is called chemical reactivity. In the chemical reactivity series, and the metals we arranged. So first one is potassium, and second one is sodium, third one is calcium, fourth one is magnesium, and fifth one is aluminium, and these metals are called highly reactive elements. And then zinc and copper, zinc and iron, tin, lead, these four elements are called moderate reactive elements. And the elements which are below the hydrogen, what are those? Copper, mercury, silver and gold, those are called low reactive elements. Children, here you need to remember one point, that why we have written here hydrogen. See, in this vertical column there is a hydrogen. Hydrogen is not a metal, but we place here. Why? Because hydrogen is also have a characteristic like metals. Metals, when they lose electrons, they form positive ions. So hydrogen is also having the same characteristic, so that we arrange here, and the elements which are more reactive than hydrogen, okay, and those can easily displace hydrogen, and the elements which are lower than hydrogen, those are less reactive than hydrogen. So now I hope that you all understand about this chemical reactivity series, so that we can easily and we can able to understand now chemical displacement reactions. Displacement reactions: those reactions in which one highly reactive element displaces low reactive element and occupies its place is called displacement reactions. Once again I am repeating the same definition. The reactions in which one highly reactive element displaces less reactive element and occupies its place is called displacement reactions. These displacement reactions are many types. Maybe the displacement reactions are happening between metals and metal salts, or the displacement reactions are happening between metals and acids, and also the displacement reactions are happening between metals and metal oxides. So some of the examples now we will discuss one by one to understand about the displacement reaction. This displacement reactions are also called single displacement reactions. Before going to discuss about displacement reactions, when we are preparing metal solutions, metal salt solutions, okay, so first we need to take a test tube and add the given salt little bit amount 2-3 grams, and to that we will add suitable amount of water, so that we can prepare aqueous solutions. So some of the examples related to aqueous solutions and metals we will discuss one by one. Here for example, copper sulfate solution, copper sulfate aqueous solution, which is blue solution, blue color. To this blue color solution we will take a zinc strip and place it inside the copper sulfate solution. The zinc metal, the color of the zinc metal is silvery white. So when we place the zinc strip into the copper sulfate solution and the reaction taking place between these two chemicals, after some time this blue color solution becomes colorless solution. Why? Because formation of zinc sulfate. Instead of copper sulfate, it slowly converts into zinc sulfate. Why? Because here zinc is highly reactive metal, so that this zinc displaces copper and occupies its place, so that due to the formation of zinc sulfate colorless solution, the blue color solution is disappears. And also we can observe one more identification, that on this zinc metal there is a metal, other metal is deposited, that is red brown color. So we can see on the zinc strip there is a red brown color metal is coated, that is copper. Once again I am repeating, we are taking blue color copper sulfate solution. To this we added a zinc strip metal, it is silvery white color. When the reaction is taking place between them, the blue color solution disappears to colorless solution due to the formation of zinc sulfate. On the zinc metal there is on the zinc strip there is a red brown color is deposited, that is copper metal. And one more example we are going to discuss in the similar way. Here we have taken again copper sulfate blue color solution. To this we added magnesium metal, so magnesium strip. So when we added magnesium strip, and again the reaction taking place between copper sulfate and magnesium, then the blue color solution slowly disappears and becomes colorless due to the formation of magnesium sulfate. And also we can observe one more identification, that is on the magnesium strip there is a red brown copper metal is deposited. So here this chemical displacement is happening. Why? Because magnesium is highly reactive element compared to copper, so that magnesium displaces copper and occupies its place to form magnesium sulfate and copper. In the similar way, one more example we have taken copper sulfate blue color solution. To this we added iron nail. Iron formula is Fe. So iron nail color is gray color and copper sulfate solution is blue color. So when we added iron nail, after some time the reaction taking place between copper sulfate solution and iron metal, and the reaction taking place, this copper sulfate solution blue color solution slowly converting into greenish solution due to the formation of ferrous sulfate. And also copper metal is deposited on the iron nail. So here copper sulfate and iron reacting together, iron is more reactive than copper, so that ferrous sulfate and copper metal are formed. So these are all happening because of displacement reactions. In all these three cases, we observed that one is highly reactive element, one is low reactive element. Here magnesium is highly reactive element, copper is low reactive element. Iron is highly reactive element, copper is less reactive element, so that these metals are displacing copper. See here in reactivity series we already discussed. See here magnesium is more reactive element, copper is low reactive element, so that magnesium easily displaces copper. In the similar way, one more example, copper chloride, it is green color solution. So to this green color solution, we have taken a strip of lead. So this lead is bluish gray color. So when we added strip of lead to copper chloride solution, the reaction taking place between them, and after some time this green color solution changes to colorless solution because due to the formation of lead chloride. And also we can observe the copper metal which is deposited on the lead strip, so that this red brown color coating we can see on the lead strip. So here lead is more reactive metal than copper, so that this lead displaces copper and occupies its place. So copper is free to move, so that it is liberated and it is deposited on the lead strip. And one more example we are going to discuss here, silver nitrate solution. We have taken silver nitrate solution. To this we added copper metal. So copper metal is red brown color and silver nitrate solution is colorless solution. So when we taken this silver nitrate solution, to this a strip of copper metal is added. So now the reaction taking place between them, after some time we can see that this colorless solution converted into blue color solution due to the formation of copper nitrate. Copper nitrate formula is CuNO3 twice. So due to the formation of copper nitrate, it is blue color solution, and the metal which is displaced, that is silver, it is deposited on the copper metal. So in this case what happens? Copper is highly reactive than silver, so that copper easily displaces silver. So silver is liberated. So children, here see here, copper is here, and where is the silver? Silver is here. So that copper is more reactive than silver, so that copper displaces silver. And one more example, if you take iron and hydrochloric acid, the reaction between metal and acid. So we all know that when metals react with acids, they produce hydrogen gas and corresponding metal salts. Here iron metal treated with hydrochloric acid. So iron metal is more reactive than hydrogen, so that iron metal displaces hydrogen and occupies its place, so that instead of hydrogen, here iron is there, so that FeCl2 is formed and hydrogen gas is liberated. So many more reactions we can give for the same way. So many metals, when they react with the acids, they liberate hydrogen gas, and according to that corresponding metal salts are formed. Similar way, one more example, magnesium metal, when it is reacted with hydrochloric acid. Magnesium metal reacted with hydrochloric acid, and then magnesium is more reactive than hydrogen, so that magnesium displaces hydrogen, so that magnesium chloride and hydrogen gas is formed. In the similar way, one more reaction we will see, metals reacted with water. See, sodium is very reactive element because it is top in the reactivity series, so highly reactive element. So when it is react with water, it causes explosion also. That much reactive, the sodium metal, very dangerous. So the sodium metal, when it is reacting with cold water or hot water, it is very reactive, so that this sodium highly reactive, so immediately it displaces hydrogen and occupies the place of hydrogen. Instead of that, what happens? We will get sodium hydroxide and hydrogen gas is liberated. So sodium react with water, forms sodium hydroxide and hydrogen gas. And the similar way we will see here fluorine, it is a non-metal. When it is reacting with a potassium iodide, Ki means potassium iodide. So when chlorine gas is reacting with potassium iodide, so chlorine is more reactive than iodine. So that this chlorine easily displaces iodine and occupies the place of iodine. So that we will get potassium chloride and iodine gas. Once again I am repeating. When chlorine gas is treating with potassium iodide, chlorine is more reactive than iodine, so that it occupies the place of iodine to form potassium chloride. Instead of this, iodine gas is formed because iodine is displaced here. And one more example, see till now what we observed, so metal salts, aqueous solutions and metals reacted, and here we will see both are solids. Copper oxide is a solid material and magnesium is also solid metal. So when this solid metal treated with copper oxide solid, this magnesium is more reactive than copper. Already we discussed. So that this magnesium easily displaces copper. So that we will get magnesium oxide and copper metal is liberated. So this is the copper. So here what happens? Both are solids. Even though between solids also the displacement reactions taking place. And one more example, and this reaction is also we will call thermit reaction. Why? Because thermo means heat, liberation of heat. So in this reaction large amount of heat is released, so that this reaction we will call thermit reaction. So in this thermit reaction what will happen we will see. See, this is called iron oxide. When iron oxide treating with aluminium metal, so aluminium is more reactive than iron, so that this aluminium displaces iron and forms aluminium oxide and iron metal. So this reaction is used when the railway tracks break up. In that, for joining the railway tracks, this thermit reaction is utilized. Once again I am repeating, here iron oxide is treating with aluminium metal. Aluminium is more reactive than iron, so that iron is displaced. So instead of iron place, aluminium will occupy, so that we will get aluminium oxide and iron metal. So students, here we discussed about chemical displacement reactions. In chemical displacement reactions, we observed that one highly reactive element always displaces less reactive element and occupying its place. Now we are going to discuss about chemical double displacement reactions. Now we are going to discuss about double displacement reactions. Those reactions in which two or more compounds combine together. When they combine, they mutually exchange their ions to form another two new compounds is called chemical double displacement reaction. Once again I am repeating the definition. When two compounds are combined together, they mutually exchange their ions to form another two new compounds is called chemical double displacement reaction. This chemical double displacement reaction is also known as chemical double decomposition reaction. So mostly these reactions occurs in solutions. In these reactions we can also see the formation of precipitation. Examples, some of the examples we will discuss for double decomposition reactions. Here we have taken silver nitrate solution, aqueous solution, and also we have taken sodium chloride aqueous solution. In one test tube we have to take silver nitrate aqueous solution, in another test tube we will take sodium chloride aqueous solution. Aqueous solutions. These aqueous solutions contains radicals, means ions. Silver nitrate salt, when it is dissolved in the water, it produces ions, silver ion and nitrate ion, Ag plus ion and NO3 minus ion. In the same way, when salt, sodium chloride salt is dissolved in the water, then we will call aqueous solution. That solution contains Na plus and Cl minus ion. So when these two test tubes are mixed together, they mutually exchange their ions, means Ag plus react with chlorine and NO3 minus react with Na plus to form silver chloride and sodium nitrate. So here two compounds are combined together, then they mutually exchange their ions to form another two new compounds, so that we will call this type of chemical reaction is double displacement reaction. Once again I am repeating, these reactions are generally occurs in solutions, because solutions containing radicals, so that they can easily exchange their ions to form another two new compounds. In the similar way, one more example we will discuss, that is barium chloride solution and sodium sulfate solution. So one test tube containing barium chloride solution, another test tube containing sodium sulfate solution, aqueous solution. In this, barium chloride contains barium ion Ba2 plus and chlorine Cl minus ion chloride, and sodium sulfate contains Na plus ion and sulfate ion SO4 2 minus ion. So when these two solutions are mixed together and they mutually exchange their ions, so Na plus combine with chloride ion and Ba2 plus combine with sulfate ion to form barium sulfate and sodium chloride. Here we have taken two compounds, and when these two compounds are mixed together, they mutually exchange their ions to form two another new compounds, that is barium sulfate and sodium chloride. One more example we will discuss now, barium chloride. Again we have taken in one test tube aqueous solution of barium chloride, and another test tube we have taken copper sulfate solution, blue color copper sulfate solution. So when these two chemicals are mixed together, when we mix it together, again they mutually exchange their ions to form barium sulfate and copper chloride. So here barium sulfate, white color precipitate is formed, and copper chloride also along with the same reaction it will form. So here barium chloride already we discussed contains two radicals, Ba2 plus radical and chloride Cl minus. Copper sulfate contains Cu2 plus and sulfate 2 minus. So when these two substances are mixed together, they mutually exchange their ions to form two another new compounds. See, in these three cases, when we observe two compounds, aqueous solutions are mixed together, another two new compounds are formed. In that, one is precipitated reaction. Here AgCl is precipitation, and in the second equation BaSO4, white color precipitate is formed. In the third equation also barium sulfate, white precipitate is formed. So generally these reactions occurs in solutions, and along with these reactions there is a precipitate is also formed. And one more example we will discuss now. We will take copper sulfate solution. Copper sulfate solution. To this copper sulfate solution, when we pass hydrogen sulfide gas, it is not solution. When we pass hydrogen sulfide gas to the copper sulfate solution, even though they mutually exchange their ions, here copper sulfate contains copper ion and sulfate ion, and H2S contains H plus ion and H2 minus ion. So here Cu2 plus combines with sulfur and sulfate combines with H plus to form CuS. It is a copper sulfide. It is black color precipitate is formed in the test tube, along with sulfuric acid is also formed. And one more example, it is very interesting example. When we see this, we will feel very happy. So lead nitrate solution. We will take in one test tube lead nitrate aqueous solution, and another test tube we will take potassium iodide aqueous solution. Now these two solutions are mixed together. The lead nitrate containing the radicals lead 2 plus, Bb2 plus and nitrate NO3 minus, and the potassium iodide contains potassium K plus and iodine I minus. So these mutually exchange. So lead react with iodine and potassium react with nitrate to form lead iodide. This lead iodide is immediately yellow color precipitate is formed. When both the test tubes are mixed together, yellow color precipitate is formed, that is lead iodide, and along with potassium nitrate also formed in the solution. And one more example, aluminium chloride. Aluminium chloride containing aluminium radical and chloride radical, and another compound is ammonium hydroxide, NH4OH, ammonium hydroxide. This ammonium hydroxide contains the radicals NH4 plus and OH minus. So when these two chemicals are combining together, chemical compounds are combining together and they mutually exchange their ions. Aluminium combines with oxygen and NH4 plus react with chlorine to form aluminium hydroxide and ammonium chloride, and the two new compounds are formed. In this, aluminium hydroxide is a white color precipitate along with ammonium chloride also formed in the solution. And one more example we will discuss, and this we all know very well, that is called neutralization reaction. Neutralization reaction means when acids and bases combine together to form salt and water is called neutralization reaction. In this we will take base NaOH. This NaOH containing the radicals Na plus and OH minus. So these are all aqueous solutions we need to take. So Na plus and OH minus. In aqueous solutions only they produce ions so that they can easily exchange their ions. So NaOH contains Na plus and OH minus ions, and hydrochloric acid contains H plus ions and chloride ions. When these two substances are mixed together, then Na plus combines with chloride and H plus combines with OH minus together to form two new compounds, that is sodium chloride and water. The sodium chloride is not a precipitation reaction. Why? Because the sodium chloride is soluble in liquid, so that we cannot see this precipitation reaction. In remaining all the cases we can see the precipitation reactions. So this chemical double displacement reactions generally occurs in solutions, so that in solutions they containing the radicals, so the mutually exchange, so that another two new compounds are formed. So today's class we discussed about, one is chemical displacement reaction, another one is chemical double displacement reactions. See, these reactions you need to practice very well, otherwise you can able to forget. So continuous practice is required, and also when you are writing chemical equations you always see that you have to write the balanced chemical equations. And the remaining classes, next class we will discuss about oxidation and reduction reactions, and also what are the effects of oxidation and reduction reactions in our daily life. In addition to this, we will also discuss how the questions will come from the exams for 10th class board exam, and how to write the answers, and these are all also we will learn our next class. Thank you very much.